નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study the question number 2 of exercise 7.1. This is the topic of standard 8 chapter number 7 cubes and cube roots. So what is the question is? Question is find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So here we have given one of the digit, let us suppose 243. Currently this is not a perfect cube number. We have to make it perfect. But how? We have to multiply some of the whole numbers by which this number can be the perfect cube. Now you remember the method that we have done in squares and square roots, right? To make a number perfect square, whatever the method we use, the same method we have to use here. First of all, we have to find out the prime factors of this number. Okay, so to find out the prime factors, what we have to do? We have to divide with these numbers like 243. See, this number is divisible by 3, right? So when we divide it with the 3, we get the 3 8s are 24 and 3 1s are 3. Now again we can divide it with the 3. When we divide it with 3, we get the 3 2s are 6. 2 is the remainder, 21 we get. So 3 7s are 21. Okay, again divide it with the 3, we get 9. 9 3s are 27. Again divide it with the 3, we get the 3. And again we divide with the 3, we get the remainder is equals to 1. So here we can write down the prime factors of this 243 as 243 is equals to, see how many 3's are there? 1 2 3 4 5. 1 2 3 4 and 5. See, currently this number, if we make the pair of the same factors, but we have to make the pair of the three numbers, right? Three digits, three same factors. So here we get one of the pair, but here we get only the two factors, right? We required one more 3 to make the complete pair of the same factors. So here that number that we have to multiply this number is what? Now you can understand, this is the 3. So we have to multiply this 243 with the 3 both the side. So if we multiply this number with the 3 here, the same number we have to multiply it to the left hand side. So right hand side, now we have the pair of the two 3 digit numbers, or the pair with the 3 same digit. Now multiply this number. Here we get 3 3s are 9, 3 4s are 12, 1 is the carry, 3 2s are 6, plus 1 7, 29. And so that here we get the same factors, 3 into 3 into 3 and 3 into 3 into 3. So now see, the prime factorization of the number 729 is such the number so that we can make this pair of the three same factors, right? So now this 729 will become the perfect cube number, right? Okay, so now let us study the question number 3. What is the question? The question is, find the smallest number by which each of the following number must be divided to obtain a perfect cube. So here we have to divide the given number so that it can be a perfect cube number. Currently it is not a perfect cube number. So the same process that we apply here, we have to apply here. That means we have to find out the prime factors of this number 128. So let us divide it with the 2. When we divide it with the 2, we get the 2 6 are 12 and 2 4s are 8. Again when we divide with the 2, we get the 32. Again we get the 16. Again with the 2 we get the 8. 2 we get the 4. Again we divide with the 2, we get the 2, and again we divide it with the 2, we get the 1. So this is how we factorize this 128. So we can write down here 128 as a multiple of how many 2? 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Now let us make the pair of the same factors, but pair of the three same factors. First pair, second pair. Now see, one of the two is remained here. In the question number 3, we have given that we have to divide this number with the smallest whole number. So what will be that number? Yes, obviously that number is 2. So when we divide this number both the side with the 2, now what will happen? This 2 and 2 will cancel out each other. Right, left hand side also we have to divide this number with the 2. So when we divide with this with the 2, we get the 6 and 4, 64. And right hand side we get 2 multiplied by 2 multiplied by 2. This is the first pair and this is the second pair of the same factor. So now see, these two are in the same number 3 and 3. Right? So now we can say that the 64 is a perfect cube number. So in both this question, both the question we have to do in the same way, but in this question we have to multiply the given number with this whole number, and in this question we have to divide the given number with the whole number so that the given number can become the perfect cube number. See, in both the case, now we get the same factors in the pair of 3. That is why this 729 and 64 will become the perfect cube number. Right? Okay. Now you can solve this type of the same question using the same method. Okay? Okay. Now let us understand the question number 4. Here we have given the question is Parikshit makes a cuboid of plasticine of side 5 cm, 2 cm and 5 cm. How many such cuboids will he need to form a cube? See, here we have given one of the cuboid. This is a 3-dimensional object. Okay, now its length, one of the side that is length is given as a 5 cm. One second dimension that is the breadth that is 2, and the third dimension that is the height and that is given as a 5 cm. So this is a cuboid. This is not a cube. Because whenever there is a cube, their length, breadth and height, all the 3 dimensions will be equal. But here, all the 3 dimensions are different. These two, yes, they are equal, but this is, third one is different. So this is what? This is a cuboid, right? Okay. Now, from this cuboid, we have to make, using this cuboid, we have to make a cube. So, some cube we have to put in, adjacent to this cube, some we have to put on the top of this. So in this way we have to make a perfect cube. But to make that perfect cube, how many such kind of cuboids we require? That we have to find out. Right? Okay. This you can consider as a brick, because in the brick is also a one type of cuboid. So using the brick, you want to make a perfect cube, then how many bricks that you require, this you can understand in this way. So now here, first of all, we know that we can write down the volume of this cuboid. Volume of cuboid, that is equals to, what will be the volume? Length into breadth into height. That the length is 5 cm, breadth is 2 cm and height is 5 cm. The total will be 5 2s are 10, 10 5s are 50. The total is 50 cm cube. This is the volume of one cuboid. Now, this is the volume we get here is 50, right? So 50, the prime factors of this 50 are, we know that is 5, 2 and 5. Now this question is same like this question. In this question, the given number is not a perfect cube. Okay, so we multiply the number with 3. When we multiply the given number with the 3, we get a perfect cube number. In the same way, this 50 is not a perfect cube number. We have to multiply this 50 with sum of the whole number so that it can be the perfect cube number. Now see, here we can write down 50 is equals to, if we put this 5 together, we get 5 into 5 into 2. Now see, to make the 3 5 here, we required 1 5. To make the 3 2 here, we required 2 2. So how we can do this? Write down 50 as it is. Here 5 into 5. 2 5 are already there. Put one another 5 in the multiple of this. So the same number we have to multiply this side also. Now the 3 5s are there. Now let us do this same thing for the 2. Here 2 is only one time. So if we make the pair of the 3 same prime factors, we have to multiply with the 2 another 2. So this same number we have to multiply this side also. Right? This side also. So see, here we make the pair of the same factor. One pair is of the 5, one pair is of the 2. In both the pair there are 3 factors. So what will be the digit we get left hand side when we multiply these numbers? What we get? 2 2s are 4, 4 5s are 20 and 20 5s are 1000. Right? So this is the perfect. Now this number will become the perfect cube number, and the numbers, the prime factors we get here is 5 5 into 5, 2 into 2 into 2. So this will become the perfect cube number. So now which number we multiply to make this 50 the perfect cube? Or we can understand that this thing by dividing the volume. Now see, this is the volume of one cuboid. This is 50 centimeter cube is the volume of the one cuboid. The new volume we get here is equals to 1000 centimeter cube. So if 50 centimeter cube, that is equals to 1 cuboid, then 1000 centimeter cube volume, then how much is the cuboid we require, right? So 1000 into 1 upon 50, 1000 into 1 upon 50. 0 0 will cut each other, 5 and 100 is there, so when we cut it we get the 20, 25 are 100. So this is the required answer, that how much cuboid we required, right? So 20 cuboids are required to make a cube using this cuboid, right? To make a cube we required 20 cuboids of these dimensions. This is the answer. Okay, you can understand this thing by also not using the volume. Here what we do, 50 we get, but it is not a perfect cube. So when we make it the perfect cube, which digit we multiply? We multiplied with the 5 and we multiplied with the these numbers, 2 into 2. So now multiply it with, we get 2 into 2 is 4, 4 5s are 20, and that is the answer, right? So we understand it by using the volume so that it can easy to understand. It can be easy to understand. Okay. So we require 20 cuboids to make a perfect cube using this cube. Okay. So this is how we can solve this type of questions. So this is all about this lecture. Thank you.
Thank you for joining us.